Hello my dear students. Today we are going to present different types of questions and problems which is going to revise on the whole syllabus in this year, and we are going to discuss their explanation in details. So let us start. Choose the correct answer from A, B, C or D. When adding 25 milliliter of hydrochloric acid, its concentration 1 molar, to 25 milliliter of sodium hydroxide, its concentration is unknown, containing drops of bromo-thymol blue, and at the end of the titration, the solution color changes from what? Here, red to blue, or blue to pale green, or yellow to pale green, or blue to purple. If you think about it, yes, it will be blue to pale green, as the solution starts from basic solution, and the bromo-thymol blue gives the blue color, and at the end point changes to pale green color. Next one, when adding 50 milliliter of nitric acid, its concentration is 1 molar, to 50 milliliter of potassium hydroxide, its concentration is unknown, containing drops of phenolphthalein, and at the end of titration, the solution color changes from what? Colors to red, blue to pale green, red to colorless, blue to purple. The right answer here it will be C, because phenolphthalein in basic solution that start from it is red, and at the end point it changes into colorless. When adding 10 milliliter of sulfuric acid, its concentration is 0.5 molar, and 10 milliliter of sodium hydroxide containing 1 molar here concentration, then adding litmus to the solution, the color becomes what? Here red, here blue, or orange, or purple. Here the solution will be purple. Why? Because the solution is here neutral, because here the number of hydrogen ion is neutralized by the hydroxide ion, so the solution here is purple in spite of its number of moles of the acid and base are not equal, but the result of concentration of hydrogen ion equals the concentration of hydroxide ion. Next one, problems. Sodium salt solution is added to 2.1 gram of hydrated barium chloride, BaCl2.XH2O, dissolved in water, then until complete precipitation of white precipitate, which is insoluble in dilute hydrochloric acid. Then separates the precipitation by filtration and drying it, so its mass is 2 gram, so the percentage of water of crystallization will be what? Given that the atomic mass of oxygen 16, sulfur 32, chlorine 35.5, barium 137. So is it 85 or 58 or 15 or 51? If you solve the problem, it will be 15. What is the answer of this problem? Here, as the white precipitate is insoluble in dilute hydrochloric acid, so it is sodium sulfate. So the reaction occurred as following, that barium chloride reacts with sodium sulfate, giving barium sulfate and sodium chloride. So 1 mole of barium chloride gives 1 mole of barium sulfate. Then, by getting the molar mass of each of barium chloride and barium sulfate, here the mass of barium chloride that gives the precipitate 2 gram of barium sulfate, so the mass of barium chloride equal here 1.785 gram, as shown on the screen. The percentage here of barium chloride in its hydrated compound, so 1.785 over 2.1 times 100, so equal 85%. So the percentage of water of crystallization here, 100 minus 85, so it equal to 15%. Next problem. A mixture of calcium carbonate and sodium sulfate. Its mass is 1.5 gram. Neutralized with 15 milliliter of 0.8 molar hydrochloric acid. The percentage of carbonate in the sample is what? Is it 60, 40, 24, or 76? If you think about this problem, you will find it will be 24. What is the solution of this problem? The solution here, the balanced equation for the reaction, calcium carbonate plus hydrochloric acid gives calcium chloride and water and the carbon dioxide gas. And here the ratio between hydrochloric acid and the calcium carbonate is 2:1. So 2 moles of hydrochloric acid gives 100 gram molar mass of calcium carbonate. So when multiplying the concentration and the volume of the hydrochloric acid to give the number of moles of hydrochloric acid, that give X gram of calcium carbonate. So the mass of calcium carbonate as shown on the screen, it will be 0.6 gram. As we know that 1 mole of calcium carbonate contain 1 mole carbonate anion. So 100 gram of calcium carbonate gives here 60 gram carbonate anion. So 0.6 gram calcium carbonate gives X gram carbonate anion. So the mass here of carbonate anion as shown on the screen equal 0.36 gram. So the percentage of carbonate anion equals 0.36 over 1.5. So times 100 equals 24%. Next question. Which of the following bears that dilute hydrochloric acid can distinguish between them? Sodium nitrite and sodium nitrate, sodium sulfite and sodium sulfate, sodium sulfide and sodium sulfite, or sodium phosphate and sodium nitrate. If you think about it, yes, it will be sodium phosphate and sodium nitrate. The only one which is a hydrochloric acid cannot differentiate between them, as it doesn't react with both of these salts, as their acids are more stable than hydrochloric acid. Next one, which of the following can be used to distinguish between the excess of sodium hydroxide solution and ammonium hydroxide solution? Iron 3 chloride, iron 2 chloride, aluminium chloride, and dilute sulfuric acid. If you think about it, yes, it will be aluminium chloride, as the precipitate aluminium hydroxide reacts with excess of sodium hydroxide and gives soluble salt, so we can differentiate between them. Next question. The number of moles of electrons needed to reduce 54 gram of aluminium ions. Is it what? 2 moles, 3 moles, 5 moles, 6 moles? The answer, it will be 6 moles. What is the explanation of this point? Here, 1 mole of aluminium ion needs 3 mole of electron to be reduced. So 27 gram, which is the atomic mass of aluminium, that molar mass of aluminium needs 3 moles of electron. So 54 gram needs X mole of electrons. So getting them correct, the answer by cross multiplication, it gives 6 mole of electrons. Next one, the BOH of 0.25 molar sulfuric acid is what? 0.3, 0.5, 0.6, 13.7. Yes, the answer, it will be 13.7. What is the solution of this problem? Here the solution, we know that sulfuric acid ionized into 2 hydrogen ion and sulfate anion, 1 mole of sulfate anion. So 0.25 concentration of sulfuric acid gives 2 times 0.25 molar hydrogen ions and 0.25 molar sulfuric ion. So here pH equal negative log of concentration of hydrogen ion, so equal negative log 0.5. So BOH equal 14 minus BH, so BOH equal 14 minus 0.3, so it will be here equal 13.7. Next one. Next problem. The siderite ore contains 40% iron 2 carbonate. The percentage of iron in 510 ore is what? Where is the atomic mass of iron? 56, carbon 12, oxygen 16. Is it 60 or 40 or 19.3 or 80.7? If you are going to solve the problem, you will find it will be 19.3. What is the solution of this problem? Here 110 of iron 2 carbonate ore gives 4010 pure iron 2 carbonate. So 510 ore gives x10 of iron 2 carbonate pure. So the number of tens of pure iron 2 carbonate as shown on the screen, it will be 210 by cross multiplication. So here 1 mole of iron 2 carbonate contains 1 mole of iron. So the molar mass of iron 2 carbonate as shown contains 56 gram of iron. So 116 gram, which is the molar mass of iron 2 carbonate, gives 56 gram of iron. So here 116 ton of iron 2 carbonate also give 56 ton of iron. So here 210 of iron 2 carbonate pure contain x10 of iron, and by making a cross multiplication we can get the mass of iron as shown on the screen, so equal 0.965 ton. So the percentage of iron here, that the mass of iron over the mass of the ore times 100, so it will be 19.3%. Which of the following graphs represent the change in the mass of sample of hydrated barium chloride when strongly heated? If you look at the graph here, and on heating it, the water of hydration will be evaporated and the mass then remains constant. So the answer is graph D. Next question. The percentage of impurities in 2 gram of ore of zinc oxide that reacted with 30 milliliter hydrochloric acid, where 0.5 liter of hydrochloric acid contains 18.25 gram of pure HCl, where the atomic mass of HCl and zinc and oxygen are given on the problem as shown on the screen. So what is here's the answer? Is it A or B or C or D? If you solve the problem, it will be number C. What is the solution of this problem? The solution here is the concentration of hydrochloric acid equal mass over volume times molar mass. So 18.25 over the volume 0.5 liter, and the molar mass of hydrochloric acid, because we dissolve this mass in here 0.5 liter, so the concentration here of hydrochloric acid equal 1 molar. Then the number of moles of hydrochloric acid equal its concentration times volume, so 1 times 30 times 10 power negative 3 equals 0.03 moles. Then here the reaction occurs between zinc oxide and hydrochloric acid, giving zinc chloride and water. So here 1 mole of zinc oxide here reacts with 2 mole of hydrochloric acid, then the molar mass of zinc oxide as shown on the screen, and gives 2 mole or reacts with 2 mole of hydrochloric acid. So the mass zinc oxide that reacts with 0.303 moles of HCl. So we can get the mass of zinc oxide by cross multiplication, which will be 1.215 gram. Then the percentage of zinc oxide equals its mass over the mass of the ore times 100, so equals 60.75%. So the percentage of impurities equal here the 100 minus the percentage of zinc oxide, so equals 39.25%. Next problem. The BOH value for acetic acid, where its concentration 0.5 molar and its degree of ionization alpha equal 9.5 times 10 to power negative 5. Is it the choice A or B or C or D? If you are going to solve the problem, it will be 9.68. The solution for the problem. As we know, hydronium ion equals square root Ka times C. since Ka equal alpha square times C, so square root of alpha square times C, so the hydrogen ion or hydronium ion equals alpha times C, so hydrogen ion equal 9.5 times 10 to the power negative 4, which is alpha, times the concentration 0.5, so equal 4.8 times 10 to the power negative 5. Then the pH is equal to negative log of hydrogen ion concentration, so negative log 4.8 times 10 to the power negative 5, so equal 4.32. Then pOH equal 14 minus pH, so 14 minus 4.32, so the answer will be 9.68. Next problem, the pH for ammonia solution where its concentration is 0.1 molar and its degree of ionization 1.27 times 10 to the power negative 2. Here, what is the value of this pH? Is it 2.9, 1.27, 11.1, 12.73? If you solve this problem, you will find it will be 11.1. What is the solution of this problem? Here the concentration of hydroxide ion equal alpha times C. So the alpha 1.27 times 10 to the power negative 2 degree of ionization times 0.1 equal 1.27 times 10 to the power negative 3. Therefore, pOH equal negative log of hydroxide ion. So negative log this value, it will be 2.9. Then pH equal 14 minus pOH. So pH equal 14 minus 2.9 equal 11.1. Next problem. The solubility of calcium fluoride in water in gram per liter if its solubility product KSB is 3.9 times 10 to the power negative 11. Is it choice number A or B or C or D? If you solve a problem, it will be choice number A. What is the solution of this problem? Here, as calcium fluoride ionizes into calcium ion and fluoride ion, so the concentration of calcium fluoride here gives the solubility degree, which is for calcium is X, and for fluoride ion 2X. So calcium concentration equal X and concentration of fluoride ion equal to X. So KSB equals the concentration of calcium ion times concentration of fluoride ion power 2, as the number of moles of fluoride ion is 2. Then KSB equal X times 2X power 2. So substituting the value of KSB, so it will be 4X equal 4X power 3 as shown on the screen. Then X equals the root 3 for this value. So we can get here the value of solubility degree 2.1 times 10 to the power negative 4 molar, mole per liter. So we get the molar mass of calcium fluoride 40 plus 2 times 19 equals 78 grams. So the mass here in grams equal concentration times volume times molar mass. So the mass of calcium chloride in 1 liter 2.1 times 10 to the power negative 4 times 1 times 78. So equal 1.6 times 10 to the power negative 2 gram per liter. Next problem. If the degree of dissociation of weak organic monoprotic acid is 3%, in 0.2 molar solution, the pOH of the solution is what? Is it choice A or B or C or D? If you solve the problem, it will be the choice C. What is the solution of this problem? Here, as we know, alpha equals 3 over 100 equals 0.03. So Ka equal alpha squared times C. So the ionization constant by substituting the value of alpha and C, so it equal here 1.8 times 10 to the power negative 4 as shown on the screen. Then the hydrogen ion concentration equals the alpha degree of ionization times C. So hydrogen ion equal 0.03 times 0.2. So hydrogen ion concentration equals 6 times 10 to the power negative 3. So pH here equal negative log hydrogen ion concentration. So by substituting the value of the hydrogen ion concentration we get pH as shown on the screen equal 2.2. Then pOH equal 14 minus pH. Then substituting the value of pH, so we can get the value of pOH 11.8 as shown on the screen. Next problem. In electroplating process takes place to plate of copper by passing half Faraday in aqueous solution of gold 3 chloride. The plating occurs to one side area, here of area equal 100 centimeter square of copper sheet. So the thickness of the deposited gold layer is what? Given the atomic mass of gold 196.98 and its density is 13.2 gram per cubic centimeter. So the choices for the answer here, is it A or B or C or D? If you solve the problem, it will be choice C. How can you solve this problem? The solution here, the equivalent weight of gold equal atomic weight over the valency. So equal here 196.98 over 3 equals 65.66. So 1 Faraday precipitate 65.66 gram. So half Faraday equal gives mass precipitated gram of gold. So the mass of gold here half times 65.66 over 1. So equals 32.8 gram. So the volume or the size of the gold layer here equal mass over the density. So 32.8 over 13.2 equal 2.5 cubic centimeter. The height or the thickness of the gold layer, volume over the surface area, so 2.5 over 100, so equal 0.025 centimeter. What are the reactions that take place at the two electrodes? Here's the solution. Here at cathode, gold ions that here reduced into gold, and the anode here, the chloride ion is oxidized into chlorine gas as shown on the screen. And so the multiplying the equation of reduction of gold by 2 and the multiplying the oxidation of chloride ions by here 3, so we can get the total equation here. 2 gold ions plus 6 chloride ions gives 2 gold, neutral, and 3 chlorine gas are formed. Next questions. Equal masses of powdered calcium carbonate were added to separate solution of hydrochloric acid. The calcium carbonate was in excess. The volume of carbon dioxide gas produced was measured at regular intervals. As shown here, the volume of carbon dioxide gas for curve 1 and 2 is more than the volume produced of carbon dioxide for curve 3 and 4, where curve 1 has higher rate than curve 2 and the curve 3 higher rate than curve 4. So here, which curves best represent the evolution of carbon dioxide gas against time for the acid solution shown in the table below? Here, the first column shows the volume of the hydrochloric acid, 25 cubic centimeter, and 2 molar hydrochloric acid. And so the number of moles here will be 50. And curve 2 or column 2, here the column 2, 50 cubic centimeter, and 1 molar hydrochloric acid, so the number of moles is also 50 as column 1. And column 3, here the volume 25 and 1 molar solution, so the number of moles is 25. So the number of moles of hydrochloric acid in column 3 halves the number of moles produced from curve 1, from column 1 and column 2. So which choice will be here the right answer? If you look at the curve here, you will find that the concentration times volume for curve 1, here the greatest here concentration here 2 molar and the volume 25, and the lower concentration 1 molar for curve number 2. So more concentration means higher rate, while the number of moles are equal in the two curves. And the curve number 3, the half number of moles by the concentration is half the concentration of the first curve, and the number of moles here will be 25 less than the produced from the curve 1 and the curve 2. So the answer here for the column 1 is 1, curve 1, and column 2 curve 2, and column 3 curve 3. The chemical formula of ester obtained from reaction of ethanoic acid with methanol is what? Is it choice A, or choice B, or choice C, or choice D? As we know that the acid, when reacts with alcohol to give ester, the hydroxide ion comes from the acid combined with the hydrogen ion of the alcohol giving the ester. So the correct answer here, it will be CH3COO, CH3, as the formed here ester will be methyl acetate. Next one, all these compounds doesn't give effervescence with sodium bicarbonate except what? If you look at the choices here of A, B, C, D as shown on the screen, the only one which is going to give effervescence, it will be choice C. My dear students, we have reached to the end of our program today. I hope you understood all the points and different types of questions and the problems that we discussed today. And so, till we meet again, my best wishes for you.